Welcome back. This is part 2 of this lesson. We're going to continue immediately from the end of part 1, so let's get started. Subnetting is the process of breaking networks up into smaller and smaller pieces. I've just talked about the class A, B, C, D and E ranges. Now historically you couldn't break them down. You were allocated one and that was it. Classless interdomain routing or CIDR lets us take networks and break them down. It defines a way of expressing the size of a network, and this is called a prefix. An example of this is this /16 network, so 10.16.0.0/16. In this case, 16 is the prefix. Now you might spot that this is actually inside of the class A network space. So class A is between 0.anything and 127.anything. And you might also spot that it's in the private class A address space. So 10.anything is a private set of addresses. But this is only actually a subset of this wider network. 10.0.0.0/8 would be the full 10.anything range. So /8 is the same as a class A network. The first octet is the network and the rest is available for hosts or subnetting. This is a /16, which means that the first two octets are the network, so 10.16, and the rest is available for hosts or subnetting. So this /16 is a smaller network within the 10.0.0.0/8 bigger class A network. The larger the prefix value, the smaller the network, and that's a useful one to remember. Subnetting is a pretty complex process to do well, but you can learn the basics easily enough. Take this network as an example. 10.16.0.0/16. If you watched my Network Fundamentals series of videos, you'll know that 10.16.0.0/16 is a range which starts at 10.16.0.0 and ends at 10.16.255.255. /16 tells us that the network part is the first two octets, so 10 and 16. The network range, therefore, is 0.0 to 255.255 in the hosts part of the IP address. Now let's say that we were allocated this range within our organisation, but we needed to break it down into multiple networks. So rather than one large network, let's say for example we needed 4 smaller networks. Well, what we can do is to subnet this network. We can break it down. All we do is that we break this network into two. The single /16 becomes two /17 networks. The first network starts at the starting point of the original network and ends at the halfway point, the point at which the second network starts. So the first subnetwork is 10.16.0.0 through to 10.16.127.255, so the halfway point. And the second network starts at 10.16.128.0 and goes through to 10.16.255.255. So one /16 network is the same as two /17 networks. But now we can use these two networks for different things within our organisation. Now we could follow the same process again if we needed more subnets. For now, we could keep the first /17 network at the top in red, but break the bottom one in green into two networks, so two /18 networks. The method would be the same, so the first subnetwork, so bottom left, would start at the starting point of the original bottom network, so 10.16.128.0. The second smaller network, so bottom right, would start at the midway point of the original network. So these two networks are both /18, which are half the size of the original /17, and this gives us 3 subnets, a /17 at the top and 2 smaller /18s at the bottom. We could follow the same process again. Remember, our target here is 4 subnets, so we can break down the top /17 network into 2 /18 networks. The upper left /18 network starts at the starting point of the previous /17 network, and it ends at the halfway point. The upper right /18 network starts at the midpoint and goes through to the end. So this is how subnetting and CIDR works. The entire internet is a /0 network. That's why 0.0.0.0, which you'll see as a default route, matches the entire internet, all the way through to a /8, which is a class A network, /16, which is a class B network, and /24, which is a class C network, and then all the way through to /32, which represents a single IP address. Now this process will become much clearer once you start using this in lab or production environments. Generally, when you perform subnetting, you'll be breaking down a larger network into 2, 4, 8 or more smaller networks, always breaking into 2 and then into 2 again. But while it is unusual, it is possible to have odd numbers. You can break a network into 2 and then break only one half of that into 2 more, and this gives you 3 subnets. And this is the example at the top right of the screen. Now this is unusual, but it doesn't break any rules. Subnetting is the process of taking a larger network and breaking it down into more smaller networks, each of which has a higher prefix, which means a smaller network. So now that you know the high-level process, I've gone through it graphically, let's take a look at this in a little bit more detail before we finish. We're going to use the same example as before, only now with more detail. So we start with a /16 network, 10.16.0.0. Assuming we need 4 smaller networks, the starting point is to calculate the start and end of this network range. In this case, 10.16.0.0/16 starts at 10.16.0.0 and finishes at 10.16.255.255. So we know that any /17 networks will be half of this size. So step 2 is to split the original range into 2. The first /17 network starts at the starting point of the original network, so 10.16.0.0, and ends halfway through at the original range, so 10.16.127.255. So 10.16.0.0/17 means 10.16.0.0 through to 10.16.127.255. The second smaller network starts at the midpoint, so 10.16.128.0/17. So this starts at 10.16.128.0 and it ends at 10.16.255.255. You've split the original /16 into 2. You've created 2 smaller /17 networks, each of which occupies half of the original address space. Now further splits follow the same process. Each smaller network has a higher prefix value and is half the size of the parent's network range. Its first smaller network starts at the same starting address and finishes halfway, and the second one starts at the halfway point and finishes at the end. In this case, we have 10.16.128.0/18 and 10.16.192.0/18. Both of these are within the larger /17 range of 10.16.128.0/17. If you just think about this process as splitting the network range in half, you're going to create 2 smaller networks, one which uses the first half and one which uses the second half. And we can do the same process with the upper subnet, so 10.16.0.0/17, so the network in red, we can split that range in half, creating 2 smaller networks. We've got 10.16.0.0/18 10.16.18 and 10.16.64.0/18. Now, becoming proficient with this process just takes time. You need to understand how to calculate IP addresses, how subnet masks and prefixes work, and then you can just follow this process step by step to break down large networks into more and more smaller subnets. Eventually, you won't even need to calculate it at all. It will just become instinctive. I know at this point it might seem like a fair distance off, but I promise it will happen. Now at this point, that's everything I wanted to cover in this lesson. I know it's been a lot of theory. Go ahead and finish the video, and when you're ready, I look forward to you joining me in the next video.